In this video, I will demonstrate how to use WinBUGS program by using the regression analysis example. First, double-click on the icon on the desktop to open the program. And I can close this window. Next, open 3 files. Go to File menu and choose Open. And make sure the file type is appear correctly on here. There's a pull-down menu to choose type file. But I saved all the 3 files as a text file .txt, so that's why I have txt extension showing here. So I have 3 files showing here. And first I will open the data file. This is my data file, and click on Open, and I will adjust the window size. And next I will open the model file. Again, go to File and Open, and choose a model file. This is my model file, and click on Open. And I will adjust the window size to organize them. And lastly, I will open the initial value file. This is my initial value file, and click on Open, and adjust the window size just like that. The next step is to load the model and the data. First, go to the model menu and choose specification, and it will show this small dialog box. And first we need to do is check the model. In order to do that, click on the file that has the model, and then make sure that the cursor is anywhere, somewhere in the window blinking. So in my case, the cursor is blinking on the right on where it says model. And then click on the check model. And notice that I get a message here. It says model is syntactically correct. So that's a good sign. So if it is not, it will show something else. The next step is to load the data. In order to do that, do the same thing. Click on the window that shows the data file, and make sure that the cursor is blinking somewhere in that window. My case is blinking right here, so that's good. And click on Load Data. And again, I got a message here. It says data loaded. That's a good sign. If it fails to load the data, it will show something else. And then I will click on compile. Actually, I have to decide the number of chains, but at this point I will say just 1. So I will click on compile and pay attention to the bottom of the window again, model compile. So that's a good sign again. And then the next step is to load the initial values. So in my case, I have an initial value file. So I choose that window and make sure that the cursor is blinking somewhere in that window, and click on the load inits. And then again, I got a message which says model is initialized. The next step is to specify parameters to be monitored during the MCMC process. In order to do that, go to Inference and choose Samples. And then you will get this dialog box. And what we need to do is type the name of the parameters to be monitored right in here where it says node. So remember, in the way I specified the model, 3 parameters were beta 0 here and beta 1 right here. And also there is the 2 possibilities, either sigma or sig2 or even tau, but in this case I will specify sig2. So I will type in those 3 parameters to be monitored. So I will say beta 0. And then notice when the correct parameter name is typed, this button where it says set is activated, and then you click, and actually that name of the parameter is now part of the node. And to do the same thing for the other two parameters. So I type beta 1, and then again click on set, and also sig2, and click on set. The next step is to actually start the sampling for MCMC, give sampling. In order to do that, go to Model and choose Update. And you will get this dialog box. And actually, the first step I always do is to update probably 1000 and then see how it will go. So I will do that. So here by default it says update 1000. So I will use this value directly and then click on update. And notice that this iteration quickly went through the 1000 samples. And then go back to this dialog box. This is where you specify parameters to be monitored. And then actually you are supposed to choose the parameters that you want to get the results for. However, if you type asterisk, it means that it will choose all the parameters which have been specified. And what I usually look at is this history. And then it will show this history plot. And essentially this is the change of the sampled values for each one of the parameters. So this is for beta 0, and this is for beta 1, and this is for sig2, and how the value have changed over the, in this case, 1000 samples. And then you can see, what you can see is that where the sample values started stabilized. And actually that will give us an idea what the value of the burn-in period value should be, which means that how many samples we are willing to discard before before recording the actual values of the samples in order to make an inference about the population parameter values. So in this case, all three parameters very quickly started stabilized after right here, which is the probably 10 or 20. So in this case, probably we don't need to discard so many samples in order to summarize the results. The next step is to get more updates and obtain summary statistics to make an inference about the parameters. Okay, so I will close this window, and then I will specify the number of burn-in period time. So let's say that I will discard first 1000 samples. So I will start monitoring 1000 first sample. And then I will specify the number of updates. So far, 1000 samples have been obtained, and let's say that I want 10,000 more. That sounds a lot, but depending on the model, it may take a lot of time. But for this simple model, getting 10,000 samples, it is not a big deal. So I will click on, make sure that I have beginning 1001 to start monitoring, and updates I will get additional 10,000. And then I will click on update and pay attention right here that I'm getting more and more iterations, and now the total number of the iterations or the samples now 11,000. And then as I specified in here, I will use 1000 first to 11,000, so a total of 10,000 samples. Okay, the next step is to look at the sum of graphs and summary statistics. Well, first I will look at the history all the time. Horizontal axis indicates the number of the iterations or samples, 1000 first. This is where the monitoring started, and up to the 10,000. All three parameters shows the quite stable samples, just like a straight band, so which is a good sign. So this is always something we are encouraged to evaluate. Another thing I encourage you to evaluate is the density. Basically, this is histogram of those sampled values. So what we should look for here is relatively smooth curve. Actually, these are representation of the numerically derived posterior distribution. So what we should expect is that the close to where we believe that the theoretically feasible shapes of the distribution. So in this case, I would say that they look pretty good. They're pretty smooth, and those two represent close to the bell-shaped symmetric curve, and this is the distribution of the variance, and of course variance doesn't distribute symmetrically most of the time, slightly in this case positively skewed, but very smooth. So I would say that we are getting pretty good results in here. And the last thing I will do is to actually evaluate the summary statistics by clicking right here where it says stat. And where it says a mean, those are considered to be a actual estimated values of those parameters. And as you can see, those values are quite close to what we have obtained from the SPSS.